All right, so this is logarithmic functions. We're going to convert between exponential and logarithmic equations. That's pretty much what we're going to do today. We're going to look at what a logarithm is, where it's used, and then we're going to convert. In the next videos, we'll tackle those other subjects. So where are logarithms used? Well, they're used when we want to compare very small and very large numbers. So if something can be really small and really large, we can use logarithms to compare them. So like magnitudes of earthquakes. We can have really small earthquakes, and then we can have really big ones. Noise levels, and then pH levels and acidity. So let's start off with saying, what does this mean, a log? And what are we talking about comparing really small, something that can be really small or really large? So let's compare the values 10, 100, and 10 million on a bar graph. All right, so if I were to do that, maybe I would start with my 10 million bar, and I'd say, oh, it's that high. That's 10 million. Now, I got a question for you. In comparison to 10 million, how high would my 100 bar be? That high? That'd be the 100. How high would the 10 one be? Oh my goodness. I don't think we would even see it. So it'd be difficult to compare those. The 10 and 100 will be way too small compared to that 10 million. Plus, 100 is 10 times the size of 10, and we would not be able to tell that at all. But if we did something that's called the log, if we took the log of each of these numbers, so the log of 10 is 1, the log of 100 is 2, and then the log of 7 is, the log of 10 million is 7. Are you getting the idea of what a log is? Well, that would make it very easy to compare, because then we would have our bar graph, 1 high, then the next one would be 2 high, be twice as high. Whoop, I made that fatter than it should have been. And then the next one would be, 2, 4, 6, somewhere like this, 7 high. All right, so now we can compare something that's really small, like the number 10, with something that's really large, like the number 10 million. We just need to remember what the log is. Does anybody have any idea, looking at this process right here, what the log is? Well, that log is just the exponent, all right? So keep it in mind what 1, 2, and 7 are. 10 to the 1 is 10, right? 10 squared is 100, and 10 to the 7th is that 10 million. Whoop. So we're just taking a power of 10, and the log is that power. All right, so they allow us to compare, if we use logarithms, and this is how the Richter scale is logarithmic base 10, we can compare the earthquake caused by a stick of dynamite, which has a magnitude of 1.2, with that 2011 Japanese earthquake, which had a magnitude of 9. All right? Well, where does the log come from? How do we know what it is? Well, you remember the exponential function we just finished up talking about? It was 1 to 1. So it does have an inverse function. So y equals b to the x is the exponential. We remember what you do? You swap the x and the y. But now how do we solve that for y? And that's our problem. So that's where the logarithmic function comes from. It's solving this one, x equals b to the y. So we have y equals log base b of x, and that's how you read it. This little number down here below, that's our base. All right, so, and you notice, comparing the two, that y is the exponent, isn't it? Over here, that's our exponent. So the log of a number equals the exponent. that you raise the base to get that number. That's what a log is. All right, so down here at the very bottom, for example, log base 2, logarithm of 32 is 5 because 2 raised to the 5 is 32. And it is written as, that's kind of cut off there, but this is the base. This is the base. Same as the base in your exponent. So we're going to do log base 2, and then it always equals that exponent, 5. And that other number is what you're taking the log of. So log base 2 of 32 is 5. And that's the way we're going to read them. All right, so we got some practice here. So I want you to think about this. There's a couple of little ideas here of how to think about it. But what I normally do is, first we're going to convert to logarithm. What I normally do is I identify the base. So there's my base. And there's my exponent. So I know it's log base 5. And I say this every time. And then that other number goes next to it, of 25 equals 2. So remember, here's your base, and there's your exponent. This one's kind of nice. It says, going that way, the base to the exponent equals the x. So you would just be doing it backwards. All right? Next one. What's the base? The base is 5, so we're going to do log base 5. That number that on the other side of the equal sign, that's what you're taking the log of. And remember, it always equals that exponent. So try the rest, pause it, and come back, and let's see what you did. All right, so I guess you're back. I erased B, but let's go ahead and work C. So the base is 25. So log of 25, remember, it's going to equal that exponent. And then the other number has to be what you're taking the log of. So log base 25 of 5 is 1/2. All right, what'd you get for D? The base is 5. So log base 5 of 1 equals 0. Next one. The base is 5 again. Log base 5 of 5 equals 1. So remember the pattern here. All right? The exponent is what the log is equal to. You've got your base. That goes down below. Now, guys, be careful writing these. This is all like on a line. All right? I don't want to see things raised up to powers. The base is actually a subscript, so it's below. Everything should be written on like it's on a lined piece of paper. All right? There's no exponent in here. There's nothing raised up above. In fact, there's just a subscript. Okay. Now we're going to go the other way. So this one is really good for that. You say this base raised to that power equals that. So 5 squared equals 25. All right, so that means that this is the base raised to that equals that. W to the n equals k. A little bit easier to convert from log to exponential than the other way around. You're just going to have to think about it a little bit backwards. All right, just identify your base, identify your exponent. That other number goes next to the log. Okay, a couple more examples. So we're gonna now use the log to solve some few problems without our calculator. So in order to do this, we want to rewrite as an exponent. All right, so my base here is 2. 2 raised to the y equals 8. Well, I know that 8 is 2 cubed, so that must mean that y equals 3. Because 2 to the y equals 2 cubed, then y has to be 3, right? All right, next one, again, base 2. 2 raised to the y equals 2. Well, there's a 1 there. You don't see it, but it's there, so y equals 1. Next one, 2 raised to the y equals 1. Well, how do we take a base and raise it to a power to get 1? That would be 0, wouldn't it? So y equals 0. All right, one more here. 2 again to the y equals 1/8. Well, let's rewrite 1/8. That's 1 over 2 cubed. I'm trying to write these neat. Sometimes it doesn't always work. 1 over 2 cubed, which we know is 2 to the negative 3, so y has to equal negative 3. Boom. All right, next couple. E. All right, we've changed bases here, so this is 8. 8 raised to the y equals 2. Okay, so this is a little tougher. So since I'm going from a base that is larger than my result, I'm thinking something like square root, cube root, fourth root. So I know that 2 cubed is 8. So the cube root, or 8 to the 1/3, remember that's the cube root of 8, equals 2. So that would be 8 to the 1/3 equals 2. So y equals 1/3. All right. Next one. Base 2. 2 to the y equals 0. What would I raise 2 to get 0? Well, 2 to the negative 1 is 1/2. 2 to the 0 is 1. Is there anything to get 0? If you remember your exponential function, remember, it never hits 0. So this is not done. This is not possible. All right. Okay, a couple more. This one's one more. This is the last one. This one's a little different because we have it here 2 raised to something equals x. So 2 to the negative 4 equals x. So x is equal to 1 over 2 to the 4th. I think that's a really small number. 2 to the 4th would be what, 16? 1 over 16. So that's what it is. X is 1/16. All right, so you should have some homework problems similar to this, I do believe. If you have any questions, let me know.